This video on the states of matter, we're going to focus on the differences between physical change and chemical change or chemical reactions. Now, the very important thing about understanding physical change and chemical change is quite important because we need to be able to describe in everyday instances what undergoes chemical change and what undergoes physical change. So let us get down to the different properties or characteristics that we're going to look for when we talk about physical change. What is a physical change? Well, a physical change is merely a change in the states of matter or the phases of matter. For example, solid, converting something solid to liquid to gas or plasma, that is a physical change. Well, plasma is kind of iffy. The types of physical changes that are very common to us is by creating mixtures or solutions, all right? Or even making alloys. Because when you mix things together, and it is very easy to separate those mixtures, all right, or solutions or alloys or suspensions. For example, a solution you can mix the solutions by putting a solute into a solvent, stir it up like salt water, and you can separate the solution again by boiling off the water, and you're left with the salt behind. And alloys is the same thing. You smelt two different types of metals, mix them together in some form of mixture to form that alloy, and then you can separate it by smelting that alloy and extracting it based on the different melting points or boiling points. Okay? And suspension is quite easy. You can go through a filtration or a centrifuge and you can separate them. Now, it is important to note that in a physical change, the properties of the elements, the compounds or substances, they remain the same. For example, H2O, whether it's a solid, liquid, or gas, well, gas is kind of not, but solid and liquid, it will still have the same properties. That means it will still have electrical region in the water molecule, as well as the positive region in that same water molecule. Well, I guess gas will also have the same thing. And these positive and negative regions in the water molecule can align itself in such a way when they two molecules of water come close together, the positive charge of area of one molecule can be attracted to the negative area of another water molecule to form what we call a hydrogen bond. Okay? So here is a quick schematic of the physical changes. Here you have a solid where everything is lined up nice and neat. Here you have a liquid where everything is still compact and packed together, but it's flowy. And then you have the gaseous state where everything is separated and the particles are going all in different directions. Chemical change. Chemical change is also known as a chemical reaction. So, when something undergoes chemical change or chemical reaction, it changes. The chemical composition of the substances change. For example, I have this square and triangle substance reacting with a circular substance. And what we have in the end is you get a triangle circle substance and a square substance. Now, the properties of this, chemical properties of this substance and this substance is different. All right? And the properties of this circle and this square is definitely different. And in most cases, under the natural environmental, natural atmosphere of chemical change in the industry, I guess you can say that, or even at home, any chemical change is not easily reversible. That means when you cook a piece of chicken, You can't uncook that piece of chicken because the chicken has been cooked. So the chicken undergo a chemical change and you can't uncook it. All right? Another example is burning. When you turn on the stove and your gas tank in your stove depletes, you can't just open up the gas tank and say, yo, all the gases in the air go in so I can burn you some more, right? No, because those gases undergo combustion reaction, a chemical reaction, and what you get is carbon dioxide and water vapor. So where exactly are you going to get your propane or methane gas? No, you can't do it. You have to find a new source of it. Now, again, the properties of the new substances that you make is different than the old substances. And in nature, most chemical change lets off heat. Most chemical change is when energy is given up in a form of heat or light. So when you mix two transparent solutions together, and suddenly you have a purple color, or you suddenly have a blue color, when you mix the two substances together, then that is a form of energy, because light is nothing but energy. And also, sometimes when you mix two stuff together, you can touch it or feel it, or you put your hands over it, and you can feel the heat. That also is an evidence that there is chemical change. That's it.